Hello students. Today we start a new topic in a chapter number 4, curve of a subject surveying. So here today we start a topic and is elements of simple circular curve. So in the last lecture we discussed about the different components or parts and its definition, and today we discuss about the elements of simple circular curve. So here first we start a length of curve. So what is length of curve? So here total length starting from the T1 to C to T2. So this length is known as a length of curve. So here if curve designated by the radius means capital R. So length of the arc is equal to T1 C T2. So you already seen in a figure T1 C T2. So this length is a total length from the starting point of the curvature to end point of the curve. So length is equal to R into delta. So here where the delta is in radian, so we use the find out the length of the curve, this equation we use L is equal to R into delta, and where delta is in degree, in the form of the degree, so L is equal to R delta pi divided by 180. R delta pi divided by 180 is the total length of the curvature, and these two equations we use if the curve designated by the radius, and second if the curve designated by the degree of degree. So length of the arc is equal to 20 meter. So length of the curve is equal to L is equal to 20 delta divided by D. So D is a degree of curvature for a 20 meter arc. So these are the final equation for finding out the length of the curve. Now next is the tangent length. So what is tangent length? So tangent length is a VT1 this length and a VT2 this length. So it is called a tangent length. So VT1 and VT2 is equal to T. So T is a tangent length. So from the VT1O we take this triangle VT1 and VT1O. We take this triangle VT1O. So tan delta by 2. Here central angle, this total angle is delta, so half angle is delta by 2. So we take a triangle VT1O. So here we take a tan delta by 2 is equal to VT1 divided by OT1. So VT1 is a tangent length T, and T1O is a radius of the curvature is equal to R. Clear? So here T is equal to R tan delta by 2. T is a tangent length, R is a radius. So R we write it here. So R tan delta by 2 is a tangent length T. Now next equation for finding out the length of the chord. So length of the chord is a total length from the starting point to end point. This length is a length of the chord. This L is the length of the chord. So your length of the chord is equal to L is equal to T1 to T2. In another word, 2 times T1 into D or a T2 into D. Clear? So this length we find out. So we take a triangle T1DO. We take this triangle for finding out the length of the chord. Now apply the mathematical formula sin, tan, cos, etc. So here we apply the sin delta by 2. We take a triangle T1DO. This triangle we take. So here sin delta by 2 is equal to T1D this length divided by T1O this length. So we find out the T1D, and T1O is already we known, it's a radius of the curvature R. So R we write it here. So R sin delta by 2 is equal to T1D. Clear? So length of the chord, we already know about the length of the chord is a 2 times T1D. So 2 times T1D, T1D we already find. So T1D is equal to R sine delta by 2. So write it here T1D value. So length of the chord is equal to 2R sine delta by 2. Now next equation find out is the external distance E. So here external distance is this distance V2C is the external distance. This V2C point, this distance is the external distance. So external distance E is equal to VC is equal to OV minus OC. So we take a triangle from the triangle VT1O. We in a last slide we discussed about this triangle VT1O. Cos delta by 2 at here, cos delta by 2 is equal to OT1 divided by OV. Clear? OT1 divided by OV. So OV we find out, and OT1 is already known, is a value of the radius R. So OV is equal to R divided by cos delta by 2. So OV is equal to R sec delta by 2. Now E is a VC is equal to OV minus OC. So OV we find out R sec delta by 2, and OC is a value of R. OC, this value is a radius of the curvature, because this is curve and R is the radius of the curvature. So R sec delta by 2 minus R, so R is common, sec delta by 2 minus 1. So it's a value of the external distance E. So these are the equation for finding out the value of E. Now next equation for finding out is mid ordinate. So what is mid ordinate? So mid ordinate is a distance between the center point of the chord, means here D point, and curvature center C point. So this distance is a mid ordinate. So it is called also worst line. Clear? So mid ordinate M is equal to OC minus OD. Clear? OC minus OD. So OC is already radius of the curvature R, and we find out the OD. So we take a triangle T1DO. T1DO, this triangle. So cos delta by 2 is equal to OD divided by OT1. So OD divided by R. So OD is equal to R cos delta by 2. R cos delta by 2. Now put the value of the OD in a in this equation. So M is equal to OC minus OD. OC is already O2C. This value is already known, is a radius R, and OD we calculate R cos delta by 2. So write it here. Now in both the values R is common. So R 1 minus cos delta by 2 is a mid ordinate equation. This equation is a mid ordinate equation. Now another topic is setting out of simple circular curve. So first of all the tangent points should be located on a ground very accurately, because in a simple circular curve all the point, when we select any area and curvature is required, so at that time set up the instrument at a point where all the points are easily visible. Now location of the tangent point. So first of all, surveyor study the work plan, then after knowing the offset of certain point on both the tangents and make on a ground. Now both the tangents AB and BV intersect at a V point known as the intersecting point. So here we already seen in a figure. So AV and BV intersecting at a point is a V point, is a intersecting point, and set out the theodolite at a V point and measure the angle AVB. So this angle is measured AVB. So this angle is the angle of intersection, angle phi. Now deflection angle delta is a 180 degree minus phi is a deflection angle. So this angle is a deflection angle. So deflection angle is a total 180 degree minus angle of deflection, angle of interaction phi is a deflection angle. Now calculate the tangent length. We already discussed how to find out the equation. So we already find out the equation in the last slide. So tangent length T is equal to R tan delta by 2. And now select the point T1 on a line AV at a distance T from V, and similarly select the point T2 on a line BV at a distance T from V. So these 2 points T1 and T2 mark on a ground. Now change of the tangent point. So here the distance of any point from the beginning of the chain line is known as a chainage of that point, and point A is the starting point of the chain, and chainage of a V, B and D are measured from the point A. So here you exactly know starting point is a and end point is a B. So here chainage of the A point, V point, B point is mark on a ground. Now chainage of a T1 is a chainage of V minus tangent length T, and chainage of T2 is equal to chainage of T1 plus length of the curve L. So here L is equal to R delta pi divided by 180. So we are already this equation we are already find out in the last slide. So L is equal to R delta pi by 180. Now another topic we start is a normal chord and subchord. So here normal chord, on a alignment of the curve, a certain distance interval peg are driven into the ground. Like the distance between the two peg is normally kept equal to 20 meter, and the distance is known as a peg interval. And if the peg are driven at a 20 meter interval, the peg station are called a main peg station, and the chord joining the tangent point T1, the first main peg station is called a first subchord, and all the chord joining the adjacent peg station are called a full chord or a normal chord. So here small chord is a subchord, and starting to end point joining chord is a full chord or normal chord. So the length of the normal chord is generally taken equal to 20 meter, and chord joining the last main peg station to the tangent point T2 is called a last subchord. Now next we start a method of the setting out of the simple curve. So here there are the main two methods, angular method and linear method. So method of the setting out of the simple circular curve. So first we start a linear method. So only chain or tape are required for setting up the curvature, and angle measurement instrument are not in use in a linear method. Only general linear linear measurement instrument is used for finding out the length and also for setting out of the curve. So method are used, very high degree of accuracy is not required because it's a simple and linear method, and only simple measurement is required. So no any major accuracy is required, and a method is used where the curve is not very short. So its linear method is a simple as compared to angular method. So here there are four type of the linear method is there. First is by offset or ordinate from the long chord, by successive bisection of arc or chord, and by offset from the tangent, and by offset from the chord produced. So these are the main four methods. So one by one we discuss on it. So we start with the first method, by offset or ordinate from the long chord. So here you exactly seen the figure. So O point is the center point of the curvature, starting point is a T1 of the curvature and end point is a T2 point of the curvature, and V point is a intersecting point of the two tangent line, and T1 to T2 is a main chord, and R is the radius of the curvature. Now let's start. R is the radius of the curvature, and O point is a mid ordinate, is a distance between the O to C, and OX is a ordinate distance, X from the midpoint, X distance from the midpoint of the chord, and T1 T2 is a tangent point or a starting point of the curvature. And here length of the chord is a T1 to T2 is a total length of the chord is a L. Now to obtain the equation for OO, this equation from the triangle OT1D, OT1 and D. So we take this triangle OT1D. Simple, we apply the formula OT1 square is equal to DT1 square plus OD square. So R square is equal to L by 2 square. Why L by 2? Because total length of the chord T1 to T2 is a L. So T1D is a L by 2. So we take a L by 2 square and OD square. This OD square. So OD is equal to under root of R square minus L by 2 no square. Now OO point is a R minus OD. R minus OD. So OO is a R minus under OD is a, already we find out, under root of R square minus L by 2 square. So is a OO is a ordinate distance of the point. And now in order to calculate the ordinate OX from any point at a E point of the curvature, so EE1 this line EE1 is equal to X is a parallel of the long chord T1 T2. So this line is parallel to T1 T2 line, and EO to cut the long chord in a G. So here G point is a cutting point of the chord. Now we take a triangle, OX is equal to, so OX is equal to EF is equal to E1D. So this distance and this distance both are same. So E1D is equal to E1O minus OD or DO. So E1O is equal to under root of E1O is equal to under root of OE square minus E1 square. So it's a simple triangulation formula, and OD is equal to R minus OO. Now OE is a radius of the curvature, and E1 is a X distance is already known, and R minus OO value. So OX value we find out from this equation. OX is equal to under root of R square minus X square minus R minus OO. Now second method is a successive bisection of arc or chord. So here exactly you know the starting point of the joint is a T1 and the end point is a T2, and bisect long chord is a long chord at a D, and erect the particular DAC perpendicular to DC at a D equal to mid ordinate M, and mid ordinate M is equal to CD mid ordinate. So we already discuss or find out the equation in a last slide. CD is equal to R1 minus cos delta by 2. So OD or CD or a CD1 or a CD2, all the values are R1 minus cos delta by 2. Now OO value is equal to R total radius minus r square minus l by 2 square, under root of r square minus l by 2 square. So join T1C, and T2C. Then after bisect the point, center point D1 and D2 mark on a ground. Then after at a D1 and D2 set out the particular offset C1D and C2D2. C1D1 and C2D2, both the value are same. It's 1 minus cos delta by 4. Clear? Because here in a last mid ordinate, means large mid ordinate, angle is a 1 minus cos delta by 2. Now here half part is a 1 minus cos delta by 4. Clear? Now another is a 1 minus cos. If we halve this point, so 1 minus cos delta by 8. Now third method is a by offset from the tangents. So the offset from the tangents point can be divided into two types. First is a radial offset and second is a perpendicular offset. So here in a radial offset, so OX, this distance, OX is a radial offset D at any distance x from the T1 along the tangent. So from the starting point at a x distance D point we find out. So T1D is equal to small x. So from the triangle T1DO, this triangle, OD square is equal to OT1 square plus DT1 square. Clear? So OD is equal to R plus OX square. R plus OX square is a R plus OX square, and OT1 square, OT1 is a radius of the curvature, is a simple R square, and DT1 is a small x square. So here R plus OX under root of R square plus X square. So OX is equal to under root of R square plus X square minus R. So it's a radial offset. OX equation is a R under root of R square plus X square minus R. Now next perpendicular offset. So here in a radial offset, radial is a this type of the not a perpendicular to the tangent, but in a perpendicular offset you exactly know tangent is perpendicular to offset. Now OX is a offset perpendicular to tangent, this value, and DE is a OX value, and T1D is a X value. Now from the triangle E1O, so from this triangle we apply the mathematical formula OE square is equal to OE1 square plus EE1 square. So OE square is a value of the R. Then after OE1 is a OT1 minus T1E1. Clear? So T1E1, here T1E1 is the same value of the DE, is a OX, and OE square is a radius of the curvature, and EE1 is a value of X, same as a T1T is equal to EE1. So R minus OX square is equal to R square minus X square. So R minus OX is equal to under root of R square minus X square. So OX is equal to R minus under root of R square minus X square. So it's a perpendicular offset value find out equation. Now fourth and last method, so by offset from the chord produce. So this method is used for the long curve, and this method is when the theodolite is not available. So in this method, first of all T1A, T1A1 is equal to T1A is a initial subchord is equal to C1. So this is a subchord C1, and AB, A to B is a normal chord C2. Then after B2D is a normal chord C3. So T1V point is a back tangent, and angle AT1, angle A1TA, this angle A1T T1A is a deflection angle. Now A1A is a O1 is a first offset. Similarly B2B is a O2 is a second offset, and D2D is a third offset. Now arc A1A is equal to O1 is equal to T1A delta. Now T1V is a tangent to the circle at a T1, and angle T1OA is 2 delta. Clear? So 2 time of the delta, and T1 is equal to R2 delta. So we find out the angle delta is equal to T1A divided by 2R. So it's equation number 2. Now substituting the value of the delta in equation number 1. So O1 is equal to T1A delta. So delta is a T1A divided by 2R. So we already find in a last slide. So T1 square and A square divided by 2R. So T1A whole square divided by 2R. So T1A is a value is a C1. So C1 square divided by 2R. So it's a O1 is a ordinate. Now next topic we discuss about the angular method. So this method we discuss in our next lecture. So here we complete our topic. Thank you.